Welcome to another walkthrough of a real-life use case of dashDB with integrated Apache Spark. Today we are analyzing historical tornado data in order to figure out the insurance risk for real estate. We start in the web console of our dashDB local system and we open the new landing page for Spark Analytics. Here we can see that one of the options to use Spark is through Jupyter Notebooks. In order to use a notebook, you have to set up a Jupyter Docker container for dashDB. You can also find here the link to the resource where you can pull this Docker container software from and all the information how to set it up. As you can see, it's actually rather straightforward, just 3 lines or 3 commands that you have to submit. Once your Jupyter container is running on the same machine like the dashDB container, you can just open its web UI with your browser. It has a few sample notebooks already available, and in this demo here we're using the Tornado clustering notebooks. So we just click on it and this opens up the notebook. And you can observe in the status bar of the Jupyter notebook here that the kernel is starting. This kernel is now starting in dashDB, in the dashDB container in Spark. So it's technically starting a Spark application that the Jupyter server is talking to. You can verify this by looking in the dashDB web console, in monitoring workloads, and then opening the Spark tab. There you can see the currently running list of Spark clusters, and we are now user Blue Admin, so we open the Spark cluster for Blue Admin. And this opens the standard Apache Spark monitoring UI. And indeed we see one application called Apache Torre, which just started a few seconds ago. And it's in fact the so-called kernel for the notebook that we just launched. Now back to the demo notebook. We can run the cells interactively by just holding Shift and pressing Return and see the output interactively. So first we have some setup cells that we can just run here to load some libraries, and also in order to set up the demo data, which you actually just need to do once when you run the notebook in your system for the first time. Now let's start the real business. We acquire the data into Spark that we want to analyze. So we load it with the construct that you can see here. It's a standard Spark syntax for using data frame, and in this case we use a special data source of dashDB for loading a data frame based on a table called Tornado. Now when you're running this on a dashDB cluster system with multiple partitions, and also the data frame in Spark is automatically partitioned and all the operations are running in parallel. If however you're using a single partition, so-called dashDB-SMP system, then you can run the next cell in order to partition the data frame in order to achieve parallel computation using Spark on multiple cores. Now we explore the data a bit further. First in tabular form, we can just see here that the records consist of timestamps and longitude, latitude of the start and the end of the tornado, so you can see the track that it took. And then we can also do some simple aggregations, like for instance sum up the tornadoes per US state. And now in order to visualize the tornadoes on a map, we first downsample it a little bit, the data, using Spark, and use the Brunel visualization library in order to create a map with a visualization of the sampled tornadoes in the entire United States. We can of course also visualize the aggregated information in the next map here, again using Brunel. We use a density map in order to see which states in the US had the most tornadoes. No surprise, it is Texas. So for the following analysis we are going to focus on Texas. So we again use Spark in order to filter out only the tornadoes that were in the state of Texas. And with that set of data we are now doing some machine learning. We want to identify the hotspots of tornadoes within Texas, so we are using a clustering algorithm for that. And we first configure the longitude and latitude of the tornado start as the features that we would like to use as input for the clustering. Next we configure the clustering algorithm itself, and we are using from the Spark machine learning library the k-means algorithm. Now we put it all together into a so-called machine learning pipeline. The first stage is the feature selection, the second stage is then the algorithm itself, and now we can run the pipeline in order to do the actual model training. Since the volume of data is not so big, this went quite fast, so just in 1 or 2 seconds. In order to see something really happening in the Spark cluster, we have here an actually meaningless cell where we just balloon up the entire data, so just that the training takes a little longer. And now I can switch over to the Spark monitoring UI again, and while this is running, and look into the Apache Torrey application, and I can see really the progress of the model training now on this larger volume of data that we are using. Switch back to the notebook again, and now we are looking at the model that we have trained beforehand. We explore what are the clusters that have been identified. So we have 5 cluster senders with longitude and latitude, and we also can immediately use the visualization again in order to put this on a map so we can see it visually what we have just learned. We can now compare this to an official map of the originator of this tornado data, and we will see that the trained cluster senders more or less make sense if you compare that to the official cluster hotspots that you see on this map. Next, we will use the model already for the first time, and we will just basically assign to each tornado of the input data the according cluster that it belongs to by doing a prediction run on the input data using the trained model. With that, we can sum up the number of tornadoes per cluster and create a ranked list of clusters based on the likelihood that a tornado occurs in which cluster. But next you want to apply the model to new data. And here in the demo we have a set of insurance holders for real estate within Texas. And we will basically use the model in order to predict, based on the location of their real estate, the cluster that they belong to, and thus basically get an idea of the risk that is involved with insuring this real estate. Again, we will repartition this data frame for the insurance holders in case this is a single partition dashDB system, and then we can explore the data set as usual, and you can see this is the raw data. So just some customer records, in fact it's mockup data and their location of their real estate. And now we put the data again on the map to get some idea about how does it look like within Texas for customers that I have insured real estate. And now in the next cell we will apply this model and run a prediction for all of those Texas insurance holders using that model, assigning them the individual clusters. And we will also immediately write back the result into a target table with the scored customers. Leveraging Spark for doing all of this batch prediction for this large number of customers in parallel, this just takes a few seconds. And now we can explore the result and look at the scored customer data, so we can see each customer to which cluster it belongs to. And again, we can use visualization also to put this whole thing in a map and have a colorized version of the clusters and the customers that were assigned to them. So finally, we will automate this batch prediction by using the one-click deployment in order to create a Spark application that can be called via one of these mechanisms, be it a stored procedure, the Spark submit command line tool, or the REST API. We do it by just selecting the file deploy as deploy to dashDB-Spark. This takes the relevant notebook's code cells and builds a Spark application with that. It compiles it, it packages it up, and it tells us how we can now invoke it. As you can see, we can use Spark submit, we can use a REST API, or we can use a stored procedure call in order to run this Spark application. So in this case, we just copy the invocation of the stored procedure and switch over to the web console of dashDB, select run SQL and paste the stored procedure call and run the whole thing. While it's running, we can actually now switch over into the Spark monitoring again and see what's happening. And we can see that actually the application that we just generated and started is now running in parallel to the notebook application. And after a few seconds, when it's done doing its batch processing, it will actually finish and it will switch from the running application section to the completed application section. And this was our little walkthrough. I hope you enjoyed it. Thank you very much for your attention. Please check out also our playlist for the other demonstration videos that we have there.